Have you ever stopped to look at a simple chicken egg sitting in your refrigerator? It seems completely ordinary. It is just a smooth, oval object wrapped in a thin shell. Most people crack them without giving them a second thought. In the US, UK, and across Europe, eggs are a staple food, cheap and packed with high-quality protein. But if you zoom out and look at the sheer numbers, the story of the humble egg becomes mind-blowing. In the United States alone, commercial farms produce over 100 billion eggs every single year. Stacked end to end, they would stretch to the moon and back multiple times. Globally, the numbers climb into the trillions. How is it possible to produce billions of eggs every week without chaos? The answer lies in an ultra-modern industrial world. It is a massive precision-engineered system where advanced biology meets state-of-the-art robotics. Every phase is tuned to perfection. From the moment a chick hatches to the millisecond an egg is placed in a carton, everything is tracked by sensors and algorithms. This is a journey of extreme efficiency, involving automated cities for chickens and high-speed factories sorting 100,000 eggs an hour. Understanding this giant food machine changes the way you look at breakfast. It's how modern agriculture feeds billions. To understand this, step inside a modern commercial layer house. It's a specialized building designed for maximum efficiency. The environment is completely controlled by computer systems. Temperature, humidity, and airflow are adjusted every few seconds. This strict control is vital. By keeping the climate steady, the farm ensures birds stay healthy and relaxed all year round. Lighting plays a massive biological role. Specialized LED systems simulate roughly 15 hours of perfect daylight every day. Computers slowly dim the lights to copy a natural sunrise and sunset, signaling ideal conditions for egg production. Nutrition is another masterpiece. Hens are fed using automated troughs that travel down the long rows of the house. This isn't generic birdseed. It's a highly calculated blend of corn, soybeans, vitamins, and most importantly, calcium. Calcium is the raw material for strong shells. Without it, a hen's body would pull the mineral from her own bones. Along with food, a continuous line of fresh, filtered water runs directly into every section, ensuring the birds are never thirsty. While the building handles the environment, a fascinating biological assembly line is operating inside the hen itself. A modern laying hen is a biological marvel, capable of producing roughly 300 eggs every single year. However, a chicken cannot physically lay more than one egg per day. The entire process takes approximately 26 hours. It begins with food. The liver transforms proteins and fats into yolk-building blocks, carried straight to the ovary. The ovary looks like a tiny cluster of bright yellow grapes called follicles, ranging from microscopic to full-sized yolks. Once the yolk reaches full size, it's released into the oviduct. This is where construction begins, in a race against the clock. In the magnum, the longest section, the yolk is coated in a thick, clear layer of protein known as the egg white. Next, in the isthmus, two paper-thin membranes are wrapped tightly around the egg white, acting like a protective skin. The final and longest stop is the uterus, or shell gland. The egg spends a massive 20 hours inside this single chamber. Here, the body pumps fluid in and begins calcification, depositing layer after layer of pure calcium carbonate onto the membrane. This shell is engineered with thousands of microscopic pores that allow the egg to breathe during its journey. Right before it's ready, the body applies a final microscopic varnish called the cuticle to block harmful bacteria. Finally, the completed egg is turned around and smoothly expelled from the hen's body, ready for the outside world. The exact moment it's laid, the egg transitions from biology to high-speed industrial logistics. Human hands never touch them. The nesting floors have a precise slope, so gravity takes over. The egg rolls onto a flexible mesh conveyor belt. Computer systems activate the belts throughout the day, moving thousands of eggs in organized lines toward processing. The speed is controlled perfectly. Too fast and they smash, too slow, and the production line backs up. At the end of each row, individual belts feed into a vertical elevator that merges eggs from multiple tiers onto a master belt. This master conveyor is an engineering triumph, often crossing open air through enclosed bridges connecting barns to processing. Digital sensors balance the traffic. If one barn sends too many eggs, the computer adjusts speeds to prevent bottlenecks. Beneath the eggs, a separate waste conveyor pulls manure out continuously. This isolation ensures eggs remain spotless. Once at the processing plant, eggs enter a sorting environment, operating at unbelievable speeds, up to 144,000 eggs an hour. The first challenge is sanitation. Strict food safety regulations require a rigorous washing process to eliminate salmonella. The eggs move onto parallel tracks and enter an enclosed washing tunnel, sprayed with warm water and sanitizing detergents. Water temperature is key. It must be warmer than the egg so the liquid inside expands, keeping surface bacteria out. Specialized mechanical brushes rotate gently over the eggs, scrubbing away dust and stains without causing microfractures. Immediately after, eggs pass under a high-pressure rinsing mist to remove any soap, ensuring a perfectly clean surface. Next, powerful air knives blow targeted curtains of high-velocity hot air over the shells, evaporating every drop instantly. Drying quickly is essential. A damp shell is a breeding ground for bacteria. Now they are ready for inspection. In the quality control zone, science takes center stage. Today, manual candling is replaced by electronic ovoscopy. High-intensity lights make the shells translucent, allowing AI algorithms to look inside for spots or irregular formations. The system scans for internal blood spots or impurities. If it detects a shadow, the computer logs that specific egg for rejection. To catch fractures cameras might miss, high-tech facilities use acoustic crack detection. Micro hammers tap every shell. Every solid egg emits a high-frequency sound wave. If there's a hidden crack, the sound wave changes instantly. Sonic sensors capture these frequencies in milliseconds. If an egg fails, a mechanical reject gate safely diverts it. Eggs that pass are perfect, but they vary in size. Before packing, they must be organized by weight for uniform cartons. Each egg rests in its own carrier clip. Ultra-precise scales calculate the weight down to a fraction of a gram. The computer categorizes each egg into standard classes, from peewee to jumbo, tracking every slot on the endless track. When a jumbo egg passes its lane, the clip releases smoothly. Medium eggs stay closed until they reach their dedicated lane. Now sorted, the eggs arrive at the final packaging stage. Packing at high speeds without shattering is a massive challenge. Specialized robotic arms use soft, flexible suction cups to lift whole batches, swinging them over to the cartoning line. The machine always positions eggs with the wider end up. This is critical for freshness, keeping the air cell at the top. This orientation prevents the air pocket from migrating, keeping the yolk perfectly suspended and the product fresh longer. Filled packages move down a closing track where lids are folded shut, ready for the final layer of data. Cartons pass under a high-speed printer that stamps critical traceability data, expiration dates, batch numbers, and farm codes. This traceability is essential for safety. Food inspectors can trace any carton back to the exact barn and hour it was laid. Finally, automated case packers stack cartons into large crates, which are palletized and moved to refrigerated storage. Millions of eggs head to supermarkets, but a huge percentage takes a different path. The industrial liquid egg market. Eggs that fail cosmetic standards are still nutritious and safe. They are diverted to specialized breaking plants for food manufacturing. Inside a breaking plant, millions of eggs are processed by automatic breakers, an absolute marvel of mechanical engineering. As the wheel spins, a blade slices through the shell while mechanical claws pull the halves apart, dropping the liquid contents. The receiving cup uses a brilliant dual-tier system. A shallow ring catches the solid yolk, while fluid whites slip through. Optical sensors monitor every cup. If a yolk breaks and mixes with whites, the system instantly diverts it to a whole egg tank. Once collected, the liquid goes through pasteurization, a precise heating process to kill bacteria without cooking the proteins. Liquid egg is heated to exactly 140 degrees Fahrenheit. Monitoring must be accurate to a fraction of a degree. After heating, it's rapidly cooled below 40 degrees in seconds, preserving freshness and stopping any chemical reactions. The pasteurized liquid is shipped in tanker trucks hauling thousands of gallons directly to commercial bakeries and restaurants. Alternatively, liquid can be sent to spray drying towers, where it's atomized into a fine mist inside superheated air. The moisture evaporates instantly, creating a shelf-stable egg powder that can be stored for years without spoiling. Managing a multi-million bird system requires smart waste management. Modern farms use circular economy practices. Manure is rich in nitrogen and phosphorus. It's transformed into high-grade organic fertilizer, sold to enrich commercial crops. If sealed in anaerobic digesters, bacteria break down manure to produce biogas, generating green electricity to power the farm. Empty shells are recycled too, dried, ground into calcium powder, and mixed back into feed for the next generation. Every coordinated technological step ensures affordable nutrition. Modern egg production is a triumph of science and logistics. Engineering ensures that a simple, fragile egg travels safely from a high-tech facility all the way to your plate with absolute precision.